we're going to examine the domain and the range of a graph. So when we think about domain, let's go ahead and define what we mean by domain. The domain is all possible input values. Okay, so all possible input values, and all possible input values happen to be the variable x. So one thing I want you to do is I want you to take a ruler, and with your ruler your ruler can only go vertical or it can only go horizontal. So I want you to place your ruler such that it's always touching your input values. In other words, your x values. So which way, and that means that I can slide the ruler. So a lot of you want to do this. You want to put it right on the x-axis like this. The problem with that is if I can only move up or down when I'm holding the ruler this way, notice I'm no longer touching the x-axis on my upper edge of the ruler. As I move down, I am no longer touching the x-axis. I'm only touching the x-axis when I'm here at one place. So that's not the correct way to hold the ruler. I'm going to hold the ruler this way, vertically, because as I slide the ruler from left to right, I am always touching that x-axis. And so let's think about this for a moment. If I'm right here on this graph, and I'm looking at points anywhere along here, every one of these points along here has the same x value, and that's the x value of, I believe in this case it's -9, but I could be wrong. 1, 2, 3, 4, 5, 6, and that's the value of -7. Okay, so everywhere along here x has a value of -7. So then that means that those are my inputs at -7. It gives me a different output if I look this way. It tells me my output is. Okay, so if I'm looking for domain, I have to have my ruler such that it's always touching the x-axis, because the x-axis is where I go to see what my input values are for point. So I'm going to start at the far left. I'm going to move my ruler and keep moving it until I hit the function. Well, the first place I hit the function is here. And the question is, what is the value of x? Well, if I look up here where I mark my value of x at -1, I know that my x is -1. So let's just go ahead, and at the top of here I'm going to make my x-axis up there at the top. And the first place where I come to my function is right here where x is -1, and it includes it. So I'm going to put in a solid dot. It can include it. Now, as I'm sliding this ruler, I have an x value everywhere on this line, because I can go anywhere and see what my x value is, and I keep touching the function until I get right to here at the end of my function, which is here at 1, 2, 3, 4, 5, where x is 5. So that means my input goes all the way from -1 to 5. So we've done little graphs like this where we look at just the x value. So I'm just looking at the x value on an xy coordinate plane. So this is my domain right here. So my domain is everything starting at -1 going all the way to 5. It's everything in between. So x is everything in between. -1 is less than 5. So my inequality looks like that for my domain. So for set builder notation, I'm going to do the set of x such that, and then I'm going to copy this information inside. -1 less than or equal to x less than or equal to 5. So that's my set builder notation for my domain. Well, what would my interval notation for my domain look like? Well, let's go back up here. Where am I starting? My lowest value is at -1. It includes -1, so remember I'm going to do that equal like thing that's being held up. And I go all the way to 5, and it can equal 5. So that's my interval notation. So now we've done domain, let's look at range. Let's define what range is. Range means all outcomes. Okay? So that is my output values, which are my y values of a coordinate. So, just like we said, which way do we hold the ruler? I'm going to say which way do we hold the ruler, so we're always getting the value of y. So, that means I always have to touch my y-axis when I'm looking for range. So when I hold my ruler this way, I am looking at all values of y. So for example, we were just to look at this x-axis here, and I were to put a number of coordinates on here, anywhere along my x-axis, we would see everywhere I go that my y-coordinate is always 0. And that's why the x-axis is the line y equals 0. Okay, just wanted to point that out because it's a very important concept. So I want to now figure out what are all my possible outcomes given this function in graph form. So I start at the bottom, the very lowest number, and I move my ruler up until I hit the very first part of my function, which is right here. So I want to know what my y value is, so I'm going to look here. My y value happens to be -1. So just like I did an x-axis here, I will do a y-axis here on the side. So here is my y-axis, okay? And where's the first place I hit? The first place I hit is right here, where y is -1. And as I keep going up, I keep touching the function, which means I keep having output values. So if I were right here, I want to know what my output is, I'd look over here and get a y value. I go all the way up until the end of the function, which is right here, which is my y value of 2. Okay, so notice that these points connect. So these points connect, this is included, this one's included, and everything in between. So now I have a sideways looking graph. If I were going to rewrite that in something that would help me see it a little better, if I write it like this, I know my lowest value is -1 and my highest value is 2. Everything in between. So my y is in between. And I put my inequalities in. So I've just written my set builder notation. So set builder notation for my range is the set of y such that -1 is less than or equal to y is less than or equal to 2. If I'm going to do interval notation, what's my lowest value? My lowest value is -1. It can include it, and I can go all the way to 2, and it includes that. So any number that exists between -1 and 2 can be an output given this function. And yes, it is a function. It is a function because it passes that vertical line test. So remember, a function means for each input, I get only one output. And that's the case with this. So is it a function? The answer is yes, it is a function.